Good morning, Cappuccino. Here is our warm-up for today, Wednesday, May 13th. Sheldon is carrying out an experiment that involves adding decreasing amounts of a chemical to a collection of test solutions. He added 60 milliliters to the first and 50 milliliters to the second. The amounts added form a geometric sequence. Find the amount added to the fifth solution. Okay, so they're telling you it's geometric. So remember what that means. All right, find which solution will be the first to have less than 10 milliliters added. And then part C, given Sheldon has 400 milliliters of the chemical, prove that he will have enough, however many test solutions he has included in his experiment. Okay, so they're telling you that 400 milliliters is enough, and now you need to prove why that's enough. No matter how many experiments he runs, he's got plenty of this solution. All right, so that's today's warm-up. First 5 people who get it correct get 5 points extra credit. Back over here to yesterday's warm-up. Find the sum of the first 10 terms of the sequence. Okay, so first of all, if you remember from the notes yesterday, there were a couple of tips I gave you. The first one is decide, are you dealing with arithmetic or geometric? So if I look at this, I'm thinking, yeah, this looks like geometric because I am not adding the same amount each time. The difference between 7 and 35, okay, and I can get difference by just using subtraction. 35 minus 7 is 28, and the difference between 175 and 35 is not 28. Okay, so it's not arithmetic, so it must be geometric. So what am I multiplying by? Well, this one I can do in my head. I'm timesing by 5. 7 times 5 is 35. And then let's test the next one. 35 times 5 is 175. Yeah. Okay, so this is geometric. So I know what I'm dealing with. The next thing is, are we looking for a term in the sequence, or are we looking for the sum? And it says sum right here. Find the sum. Okay, so I know that I'm going to need to use one of the formulas that has an S sub n. So S sub n, geometric. So then I grab my handy-dandy formula packet, and I look for S sub n for geometric. And here I have 2 choices. One is infinite, and the other one is finite. And so this one says the first 10 terms, so it's not infinite, so I'm going to be going for this one. Okay, so my formula is going to be S sub n is equal to u sub 1 times r to the n minus 1 over r minus 1. Oh, by the way, in math space, I mentioned this before in the notes on another day, but in math space they don't use u sub 1, they use the letter a. Okay, so watch out for that. In math space they have slightly different formula variables. Okay, so when you're doing these problems in math space, u sub 1 is the letter a. We put that into notes before, but in case you forgot or you didn't watch the notes. All right, so do we have enough information now to do this? I want the sum of the first 10, because it's the first 10 terms, is equal to the first term times the common ratio, that's 5, to the n, okay, n is 10, minus 1, divided by r is 5, minus 1. Okay, so I can just do this on my handy-dandy calculator. I'm going to have 7 times, where is it, 5 to the 10th minus 1, all divided by 4, because 5 minus 1 is 4. I can do that in my head. And I get my answer, 1708984.2. Let's put in some commas to make it easier to look at. 17 million. All right, that's going up fast. Okay, so that was the answer to problem number 1. Problem number 2, find the value of the common ratio. I forgot to write of the common ratio if the first term is 11 and the sum of the first 12 terms is this. Okay, so find the value of the common ratio if the first term is 11 and the sum. Okay, so here's my key words. They told me I have a sum, so I know I'm going to look for my formula I'm going to use is going to be an S sub n. And they tell me I have a common ratio. That means it's geometric. Geometric. So I know I'm going to use the same formula that I just used up here. S sub n is equal to u sub 1 times r to the n minus 1 over r minus 1. Okay, so I have the sum. The sum is 2,200,000 2,922,920. I have the first term. That's 11. Okay, that's my U sub 1. And I don't know the common ratio. I do know that it's first 12 terms. So that means n is 12 minus 1. Okay, this is my n. This was my U sub 1. And all divided by r minus 1. Okay, so I tried playing around with this to see if I could figure out how to solve it algebraically, and I couldn't. I got stuck. So I said, well, let's use our handy-dandy graphing calculator. So I can just put into my calculator. Do I ever have it in there already? No. Okay, I actually did play around with this, and I simplified it some, and then I gave up trying to simplify it. So I actually put it into my calculator slightly different. What I did is I divided both sides of the equation by 11, but I'm just going to go ahead and put it in as is. See what happens. Okay, 2,922,920. So remember, when you want to use your graphing calculator to solve an equation, you put the left-hand side in as one equation, and then the right-hand side as a second equation. So 11 parentheses r to the 12th minus 1 divided by r, got to use parentheses on this one, r minus 1. Okay, be careful with your parentheses. Let's graph it. You can already see that I kind of did something crazy with my window, but not crazy enough. I know that y equals 2,922,000. So on my window, I need to make sure that my y value goes up to past this. So I need, let's do 3,500,000. Let's try that. Aha, now I can see it. And then we're going to wait for this one to show up in red. There it is. And I'm looking for the intersection. So second trace, there we go. I want the intersection. And first curve, yep. Second curve, yep. Guess, yep. There it is. X equals 3. X equals 3. So R is equal to 3. And that's it. Bam. Okay, and then you could try it out. You could make sure it actually works. You could test it and say, okay, so S sub n is equal to U sub 1 times 3 to the 12th minus 1, all divided by 3 minus 1. And let's see if we actually get this. Okay, so we can check it. We can check and make sure our answer is right. So just like I did this previous one, I'm going to go ahead and enter this in, times 3 to the 12th minus 1, all divided by 3 minus 1 is 2. And I get the correct answer, 2,922,920. Ta-da! All right, so that was the answer to yesterday's warm-up. Good luck with today's warm-up. And I did want to mention that seniors, you're done. Seniors, you are not responsible for any more material. This is it. I just wanted to recognize that we have covered pretty much every single topic in IB Math SL at this point. So if we were to look through our formula packet, we've now just covered all of these formulas in the past couple of weeks. Okay, our first year in IB, we covered all the logarithm rules. And the binomial theorem, we didn't do a lot with that. It was kind of like a side note, but we did talk about this, mostly in terms of probability. Okay, we did this with probability, and same with this. Okay, so vectors. We actually skipped this entire section, and I don't feel too horrible about that, okay, because chances are with whatever mathematics seniors that you go on to next year, they would not expect you to know any of this. It's not a standard part of a pre-calculus or calculus class. All right, statistics and probability. We covered all of this. We did all of this. Holy cow, that was a lot. Functions and equations. We covered all of this. Okay, there's one thing in here that we did not talk about. That's double angle formula. And the double angle formula comes from another formula, which IB did not require us to know. So I thought that was kind of crazy. It's like you can't prove the double angle formula without, I can't even remember the name of it, without the sum of angles formula. I can't remember what it was called. So anyway, so we did not talk about double angle formulae. So HL students, my juniors, next year we'll be talking about that. But this is just, another formula that you can use when you're trying to simplify a problem with trigonometry. So my seniors, when you get off to college next year and you're doing trigonometry in your pre-calculus or calculus class, they're going to give you a whole lot of formulas that are all equivalent to each other, and you can interchange them to help you work through the algebra in a problem. Okay, so don't be afraid of it just because we never worked with it. If you have sine 2 theta, you can change it to 2 sine theta cosine theta. Okay, they are equivalent, and that can help you then maybe factor something and solve for something. Okay, so just keep that in mind. These are just convenient to help you simplify trigonometric expressions. All right, we did all of these. Calculus. We did everything here. Everything. All right, so looking good. We covered all of this stuff. And for my HL students, for my juniors, we're going to keep working on a little bit more material. But seniors, I will be posting more information about your final exam, hopefully later today. I have some ideas for how it's going to work, but I just need to work out the details. Okay, so have a lovely day. There's no notes today, and there is no other assignment. Everybody gets a little holiday today. Tomorrow I'll be coming back with a new lesson for juniors only. So seniors, if you want to do it, you certainly can, but this is all that's going to be through here is all that's going to be on the final exam for my seniors. Okay? More information to follow. Have a lovely day. Bye-bye.